welcome. Thanks so much for coming. It's a great pleasure to be able to introduce our own Robert Botto. I think I have not seen you wear a jacket. No? Yeah, it's a very special. So that's the word the price of admissions itself. Mary, thank you for helping to coordinate all this. We feel better. I'm Rich Schweitzer. I'm the academic director. I had the idea that we should run some workshops to expand the community, sort of build a sense of community. And some of the technology that we have coming online, I'm very excited about. The video systems, something we've been talking about for a while. So I'm really excited about this stuff. I'm happy that you're here. I'm also cognizant that we haven't drawn in the demand that I was anticipating. So building
people online too.
Oh, that's good to know.
Yeah.
But anyway, thanks for coming. I look forward to getting to know you as well. Robert.
Hi, Robert Botto for the WBL Lab, of course. So we hope to be the first of a series of seminars that will focus on technology at the lab. Video is a underlying base technology that we use for a lot of different measures. So we're going to start with that.
Robert, can you find just like taking questions as we go?
Absolutely, yeah. Any questions, please? Go. Just generally, technology is expensive, not just the hardware, but just the expertise that we end up having to that we develop when we bring on new technology. So it's a real give and take sort of dialogue with our research community to find out what will people use, where are efforts best directed, that we get kind of return on that investment. So anything that sparks your interest here in this talk, you want to talk to us about, whether it's a deeper dive into this stuff or other technology areas, just reach out to us. We're always excited about exploring new things. What's next? So video. Kind of broke it up into 5 general stages. We'll think about what your sources of video will be, what we might have to do to then pre-process that video before we get into any analysis steps, what might have to happen after that before we deliver whatever it is that you need back. Sometimes it's video, sometimes it's signal text output. We'll get into what those things might be. So video sources. In our lab, we have webcams on the PCs and laptops. We'd be familiar with. We also have a state-of-the-art newer network camera system. It is built into we have these smaller breakout rooms. If you're not familiar with the lab, we have 2 sort of large scale rooms with 20 seats each, where we can do most of our at scale research. We also have 6 smaller rooms where people can break out into smaller groups, or we do a lot of physio research in those, eye tracking, stuff like that. Those 6 rooms have built-in camera systems, and we'll go through a bit of those, some detail on those. You might get video from an online recording. You might have participants at home using their own webcams. You might be using some teleconferencing software like Zoom has been very popular. It has a lot of challenges, and I'll go through some of that. Generally, WebRTC is sort of the underlying technology behind networking. I think there's alternatives to Zoom that we can explore as well. You might just have pre-recorded content. We do. I know. I personally help with analysis of video content that we get from some of our research partners. A little bit outside of the normal behavioral lab working flow, but that is another common use case. So I mentioned we get the 20-seat labs. There's a little pop-up web camera on each of those. We can use that in a variety of ways. Really, mainly two areas. We'll say first, local recording. This is something we've been doing for a long time. There's web recording software built into the PCs. If you wanted to just run something as a survey, some kind of experiment in the lab and say, usually do this, we kind of realize like later on, oh, I really would like to have some webcam footage of this. We can have our RAs go around and sort of hit record on all the machines or even instruct participants. And it'll make a recording locally on that computer. Alternatively, you can build something into some web content that you develop. So here's an example of me using something called camera tag, which is a WebRTC technology embedded in Chrome. So some of the
So you're saying the public survey could record.
could record webcam, absolutely, using a number of different technologies. It's sort of using JavaScript ultimately inside of Qualtrics or anything else.
And are there scholars doing it now? Like, are any faculty?
Yes. Much of what we've done that for ends up going into a workflow that involves mostly doing audio analysis, taking transcriptions out of it, running that through some maybe natural language processing stages and outputting affect measures, other things, turn taking measures, stuff like that. So that's related to video analysis in the audio domain. So we've definitely used it a lot for that. Open to other ideas. I'm sure there's some I'm forgetting.
Is anybody using the videos in the breakout rooms?
A little bit. So we're doing some physio recording now, and they're being used primarily as like a quality control measure. Also, just for real-time communication. So you might put an EEG cap on somebody, have them do a task in a room, monitor them from our control room, and then they might raise their hand when they're done and you notify. So we can use them in a non-recording, like real-time way, just to monitor what's going on in those rooms. It helps a lot. I'll show you what the control room looks like.
Just to motivate just a little more why we would be interested in this technology. I'm sorry, I come in with very little background.
Sure.
But would you mind telling us maybe just one or two things that people have used this for that is kind of a cool way to use this? Like, what do people want to know when they use this technology?
Right now, a big thing is facial expression analysis.
Facial
expression.
Yeah.
Which is like tied to, but not necessarily emotion.
Yes.
Emotion analysis. So you might want to draw inferences about emotion, and I'll go through. I'll show you some of the software we use for that and all that. So that's a big one. Again, audio transcription is big. I'd say those are the two primary uses we've had.
And audio analysis as well, so that you can
Some
get
audio
sort of
analysis.
kind of emotion from voice.
Right. There's some, we don't have any commercial software packages that do that. There are open source ones that some faculty I know have been using. I'm very interested in that. I mean, and our colleagues in linguistics, of course, have lots of tools they use for that kind of research. But yes.
I have just one follow-up on it. So you were saying that physiological tools are often, so is there like certain things that are in use in the lab in general right now, or is it you bring in the physiological?
So we have, so if you want to count eye tracking in there, we have eye trackers. We also have some wearable, lightweight, like connect wireless devices that can collect skin response, so like EDA or TSR responses, as well as heart rate through PBG on the finger. We can also do more like EEG style heart rate. And getting anything with EEG, EKG. With EEG, it's more of a bring your own device. We never purchased any headsets there. We've worked with them. We're actually running a number of EEG sample collections right now. Yeah, this most of it would be like hard skin. So just getting back to this, local recording, it's kind of easier to implement, but you're relying on a lot of real-time effort that people can make mistakes in video labeling, forgetting to record, stuff like that. If you're doing online, you have a lot more control. You sort of have to front load it. You have to build it into your experiment. So there's kind of a cost benefit analysis you would do for that. So here's the breakout rooms. Here's a picture of one of the 6 rooms. You'll see the 3 cameras here. There's one fixed camera in the ceiling, and then 2 pan tilt zooms facing one another. The idea being that we're able to capture a sort of nice head and shoulder shot over the shoulder of two people in a conversation. That software is controlled specifically by this package called Axis. The whole thing's on a closed network. It's not connected to the internet. We control that from this software in the lab space. Here's a floor view. This is actually, it has been the lab. This is a floor plan of the lab space. Do I have a? Yeah, there we go. This is the main hallway. So this is where like participants come in. 2 main rooms here, control room here, breakout rooms here, 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 and 3 out in the hallway. So this is actually a view from Axis. You can use this floor plan to click in and view the camera setups in each of those rooms. Here, for example, is one. We're looking at breakout room 406 here. And this is obviously the ceiling and the 2 overheads. Nobody's in the room at this moment. From here, you could initiate a recording. If you wanted to just say do a recording manually, fine. This is the view from our control in the control room space. Here we have some of our staff sitting in an example of how you might frame video content like this.
Anyway, so just go back.
Yeah.
So here on the bottom, those are from the cameras
Yeah, those are the cameras in the walls.
on each side. The top one is from the camera at the top of the.
Yeah, that we have one sort of bird's eye view camera just fixed in the ceiling. So if you're interested, say, in their interaction, you might only use the 2 camera feeds at the bottom. These are 3 individual. And then there's an example of just you can manually just start a recording any way you want. You can also schedule recording. So say we have a session running and we know we want those cameras just running for 2 hours every morning, then you can schedule that. And they'll be exported then to some file share where you can get to them.
And so we can then save these recordings.
Yep.
And then we can run them through like the motion.
Then you would run them through some further analysis. Yep. Yeah, so this is still just in the video, sort of in that 5-stage process flow. We're still in kind of the first stage here, just collecting how we do it, like collect video content. And so we'll move on to pre-processing. So from there, you have video, whether it's from network systems, webcam, or elsewhere. You may need to do some pre-processing. So I mentioned here some tools for pre-processing. FFmpeg or Handbrake are 2 of them. I tend to use FFmpeg when I need to do any kind of manipulation. So what kind of manipulation are you going to need to do? You might need to crop some video. You might need to, and I'll get into an example where that's like commonly used. You might need to, and this is a big one, you might need to transcode that video. And we'll talk a little bit about video streams. Depending on what kind of analysis you're doing, some tools require a specific video stream encoding. And so you want to get that, ideally, you want to get that right on the recording step, because any transcoding we do here, mention here, will potentially lose some of your image quality. And the higher quality your image coming into the analysis step, the better your analysis is going to be. You don't want to introduce noise, but ultimately you are going to introduce noise at this stage. At this stage, you have to. You might also adjust frame rate. We've done that before where we know we might have video at 30 frames a second, but processing that takes a very long time. So we might downsample it at this stage so that at that kind of further stage, we're able to get the analysis done in a reasonable window of time.
Well, I guess, like, do you help, or was there like a word research, like would they help to do this?
Sometimes they do, sometimes I do, sometimes people do it themselves. It really is sort of case by case. A lot of stuff can be done. I can program a lot of stuff in bulk and sort of do batch processing once we know what we have to do. So once we have a plan in place, we can maybe I can kick this off as a interim step in our processing. So it might be on us. Somebody else might be using a tool that they already have. And especially if they're doing specific cropping, for example, like a researcher might want to have control for that. Let me see what's coming up. So I just wanted to mention quickly, like when you have, because this might come up when you're doing video with the behavioral lab. You might say I have an MP4 file. Just know that an MP4 file is just a container inside of which there are multiple streams. So the raw streams in 2 MP4 files might actually be different, might have different encoders, might have different audio encoders. So this becomes relevant if the analysis step and some of the, especially the automated facial expression stuff, is limited in the encoders that they support. So we want to always make sure that we're matching as early as we can in the process, the encoders that we're going to want to use at the end. And so just a little bit of a representation of why like 2 MP4s might not exactly be the same file. They might have different types of video streams inside of it, for example. And then also, depending which tool you use kind of depends on where you're comfortable working. This is like FFmpeg is command line. That's what I usually use. If you're not comfortable there are things like Handbrake that have graphical user interfaces to handle some of this transcoding or remux. You might hear like remuxing. That's where you're like moving one stream into a new container without re-encoding the stream. So here's an example. I have recorded this the other day using Zoom. If you've ever used Zoom for recording, you know that you get these sort of tiled gallery view mosaic videos. But down the line, your analysis might require only like one video per person. So you need to sort of break this up in 2 dimensions. So here is an example where I used FFmpeg to break this up into 3 separate videos, just using the sort of crop size, and then with video or any digital image, your coordinate system 0, 0 is in the top left here, and they X and Y kind of expand positively in these directions. So you can just define using some macros here what areas you want to pull out the videos. And this is people have been using this a lot over the past couple of years, as you can imagine, when they're collecting video. Using Zoom and then running individual analyses on those. So if you got your video stream encoding correct, you've done any kind of other editing you need to do in the video. Obviously, time editing too. You might, in fact, here, I think I cut the first 50 seconds also out of the video. So you might have done some pre-processing there and moved on to analysis. So what kind of analyses do we do? I mentioned 3 here. AptX, FaceReader are both facial expression analysis tools. Transcribe is one we can use to extract the audio into a text format. AptX and FaceReader, they use machine learning to automate that kind of analysis. The language of the analysis and the practice is based in FACS, the facial action coding system for the most part. So we'll get these sort of emotion categories out of a tool like that. They infer emotional intent. They're labeled joy, fear, surprise. But ultimately, they actually come from these action units themselves. The action units are more facial, muscular. They're just eyebrow raise, lip curl, something like that. And there's a larger array of those. You'll see different tools will output different numbers of them, but usually between 20 and 30 different muscle group activations. And those are not necessarily like encumbered with this emotional intent. But I mean, we'll get them all out of, and I'll show you some examples of that. So tips for analysis. Yeah.
So you cannot use the facial action coding system for photos then? Can you?
Oh, you can.
Yeah.
It's you can do it. In fact, I think initially the way I think the pre-computer hand coding was done was like sort of frame by frame looking at. But if you think about it, a lot of especially once you kind of aggregate up from say just the facial aggregations to some kind of emotion category, really there'll be almost a string of different facial muscles, like muscle movements over time I think has a lot more information in it than just a single frame. So I'd be careful of using that, but absolutely you can. Yeah. And in fact, I think a lot of the early literature is mostly on photographs.
So if you have a control photo of someone, it would be much more likely.
If you have, so a lot of these do use like rolling baselines too. So they do try to baseline for individual differences.
And so you get emotions over time, right?
Absolutely. Yeah. Emotions over time is kind of the output. We'll look at some visualizations of that. So tips for good analysis, again, good quality video. People you might hear garbage in, garbage out. Make sure it is as high quality as it can be. controlling for subject lighting, posture framing, all of that is really important. Somebody can, it's an argument for doing a lot more of this video acquisition in the lab. The more control you have over lighting and all of that, the better your output's going to be. If you do have people just like recording at home, you're going to have to really coach them in how to best record themselves. Know there might be limited support for the file formats and codecs. Know that sometimes the processing takes a long time. Oh yeah, and we'll get into file exports, but get everything out. And this is really important. When you're designing your experiment, test the full workflow. Go through this whole analysis step, look at the outputs before you scale up and start running the lab. Because we've been in a situation before where we have a lot of videos and there was something we hadn't thought of. And now we're tied up going back to the pre-processing step, trying to fix problems. So just doing a full workflow is really important. Here I actually did a video. We'll see if this works. What you're looking at here is a software called iMotions. Inside of iMotions is the AppDex facial expression analysis tool. There's a way you can use it for seamless presentation. We can use it that way, but in this way, we're just going to import videos and then run some analyses. Let's see. I have to go to the now. I'm going to talk through this. I think this is about a minute long. I think I'm just here, a little hard to read. I'm choosing a folder inside of which are videos of participants. I think in this case, there's only the one. I'm going to load that in. I think you'll see here, yes, it's me sitting at a desk. I'm then going to go to post-processing and select the Affectiva AffDex algorithm, and it's going to run. This will probably take 20 or 30 seconds. Yeah, there you can see some progress. So the process being loading videos into the software, selecting them for pre-processing, waiting out the pre-processing step. Should be done soon. I can probably actually skip.
So this is Affectiva.
Yep.
In real time.
In real time. Yep.
The video.
So now we'll just go to the next one, I think. There we go. So we've just run the analysis. Here I am. Here are pause on this.
Ray, you look so happy.
I didn't realize there was a that is just going to get annoying. I believe what we're looking at here are, I apologize for the video resolution. It's actually pretty hard to see. But so we've run it. These, I believe, are the emotion categories. So yeah, so this one right here, I'll take my word for it, is joy. This is contempt. This is fear. I mean, I don't think in the span of 20 or 30 seconds, I really experienced all of those emotions. So, take them with a grain of salt. But you can see here playing back in real time, those emotion categories as determined. I believe that. Let's watch this video. I think I'm going to go. Or maybe not. So
Sorry, is that what you're looking at, or
this is
tracking your emotion through your eyes?
So notice there's the box around my face. So what it's doing is it's measuring facial landmarks. And then.
Oh, I see. So it's more your facial, not just your eyes.
Right, that's right.
Oh, absolutely. Yeah,
I'm sorry, I thought we were looking at eye
No,
location.
the eyes are only small. They are part of it. The muscles around your eyes are part of it. For some of them, especially like surprise, the eyebrow raise is a major indicator of surprise. But also the muscles around the mouth, the cheeks, forehead, like
Yep.
brow fur.
But even, this is a great video, so your face isn't a big
So
part of the
what-
video.
What's
You're
good
not
about,
looking-
right, what I like about this is it shows how these algorithms used to be a lot more sensitive to requiring really like a head-on. The fact that this is in sort of 3/4 profile, I'm wearing glasses, there's a shadow on my face, it's still doing a very good job picking up my face and being around. I mean, whether we would have gotten better data if I was more, directly, probably, but it's able to do something with this at least, which is promising.
And what's the curve depicting? Is that the intensity or?
So that's a very good question. I think they recently updated the algorithm, and I have yet to get like a good documentation on it. In the past, it's been more of a probability of for these has been like a probability that the individual has this emotion state, as opposed to the activation units. And there is more a measure of activation, of intensity of activation. So it kind of depends whether you're looking at the emotional category measures or the
But it doesn't add up necessarily to 100%.
no, there's no model of that. No, not at all. They're all independent. I know it's.
Yeah.
There's none of them have given me a good like statistical model of what that is. And there's other algorithms too, and sometimes it's more of a measure of likelihood. It really depends on the software you're using. I think with Nuldus, they do something like probability or likelihood for the motion categories, but for the action units, it's these sort of more like categorical activation. And I think that actually comes from the FACS system. It's like 5 different labels of.
Is there anybody using this now?
Yes.
Yes,
you are. Oh, yeah.
Oh,
What are you using it for?
We did like Zoom exercise where people connected with each other, like a meditative exercise. And then we measured whether we wanted to see whether they're synchronized, they're smiling.
That's interesting.
Like,
Yeah.
analysis is still ongoing.
sort of synchronized smile. Uh-huh.
Yeah, emotional like contagion things. We in the distant past we used it for that.
So
With
the
Seagal.
people who were more synchronized smiling reported to still more connected.
So it was in time.
Yeah,
Okay.
so I'm still figuring out if that is how that.
Pages. Speeches.
So yeah, we're going from here. And I think these are just behavioral ones. So you get just head position. I think that's all these 3 are. I think in this video is an example, yeah, of exporting this data. So of course you can get this out in tabular format. And I will pause and sort of wave my hands around this. Very hard to read. So I think these numbers here are most of the motion categories. They're just numbers between 0 and 1. For the most part, over on the right, we get into the action units themselves. I think you do get a usually get a valence measure, which is probably if it's -1 to 1 or like a circumflex model along with activation intensity.
A minute ago, you said, so you can see this is good data. How do we know that? Is there a metric to figure out whether it's good data? Or were you just meaning that it's moving so we can tell it's picking something up?
I think by good in that sense, it was so there's a couple stages to the facial expression analysis. One is just identifying a person's face in video frame. So the only quality metric you get out that you can sort of trust in a way is how many frames is their face. And that was like 100%. So that's in some sense good quality. It didn't struggle to identify a person. Beyond that, do you have control measures for, you could try to validate if you had some sense of when you would expect a certain, you could maybe have someone hold a resting face for a period of time. Like that's very common. That used to be very common. Hold a baseline resting face. You might even instruct them to, again, there's a bit of argument over whether like a spontaneous gesture, spontaneous facial expression movement is different from a directed one.
Mhm.
But you could certainly tell someone to make certain faces and sort of look for that.
Mhm.
When we've done some large scale video analysis for our quality metrics and just for validation, usually what we do is just, if we know when a person is supposed to be on camera and not, we go back and just check, is there a signal there? Does the signal go away? Or we expect it to go away? That's as close as we can usually get to a real data quality measure at this point. We might also just look for internal validity. Like, does it make sense if somebody's angry and happy at the same time? Or like, or if you see that, what does that mean? You might look. We haven't dived into that. Yes.
And you can obviously pick up, I guess, when somebody's not paying attention, like if they get bored with the whole exercise. or something.
Absolutely. And I think that's where this is used a lot in like online, like proctoring of examinations
Yep.
In the industry, and they use it for attention. Yeah. And in fact, I mean, this kind of software is even used for in the real world in, say, for drivers, and in addition with like with eye tracking in cars and pilots, things like that, to look for fatigue and other things, other behavioral measures. All right, so I think those are the only videos there. Then for post-processing, we're going to export data for you. We might be merging in data from other sources. So let's think about what identifiers you might need to maybe link this back to survey data, demographic data, something else you might have, or other time series data you might have, whether it's like physiological data, maybe eye tracking stuff. We've done work where we've looked at the facial expression stuff and used eye fixations as a sort of time unit of time. So yeah, video metrics, the data quality metrics, just, how many frames was there for dates. For example, if you're doing the facial expression stuff, you might want samples or stills from the video. You might not want to see them. You might not be. So I've worked with data where the researchers themselves had to remain blind to the video. So only maybe research assistant had access to the video. All we delivered at the end was some data. So we can take care of that for you.
Wait,
We might need to archive stuff. What's that?
this all link with you for us?
Yeah. I mean, well, depending on the scale, depending on the scale of the project, and we have to. But I mean, certainly we can help you with like, it's just a matter of like RAs. If you want to identify an RA, who would maybe handle some.
Oh, can you train RAs that we supply?
Oh, yeah. Yeah, and we can make software available on remote servers. But yeah, so we might want to clean up data, because a lot of times with images of people, there's governance and regulations that need to follow for privacy. So we do steps here where we clean things up, make sure that we delete what we need to delete, make sure we keep what we need to keep, so that we do replication if you need to in the future, like that. And delivery, we just use usually Dropbox or Box or anything like that. And again, we can, using access control, whoever needs to see the data, we can share with them, and not others. Just let us know early what your expectations are, and we can accommodate and build out a system for you. I think that's kind of, and happy to talk more. Actually, brought a laptop that has iMotions on it. If anybody wants to do some live demo, we can sit them down in front of the webcam. I showed you post-processing, but you can look at some of that data in real time. The sample rate won't be this, it'll be a coarser sample rate, and it won't, and the probabilities themselves might not be the final ones, but you get a preview.
Who are the subjects? They're all students, all Penn students?
Mostly in our lab, it's going to be Penn students. Yes. We're not exclusively Penn students. We are open to anybody. And then again, if you're working online, you might be using another online panel providers.
If one was, well, there might be all kinds of privacy issues around doing this on anybody but Penn students. Yeah,
Oh yeah, no, they're
we're limited to Penn students, right?
we're not limited to Penn students at all. No, just
Yeah.
there's certainly a responsibility when you're working with, or obviously responsibility to inform the person that they're being recorded and what's going to happen, who will have access to this recordings and for what period of time. But if you follow all of that, there's no restriction.
Do you ever take your lab equipment into a off-site setting to interview people, or how does
It's been
that
a
work?
while since we've done something like that, but a lot of this, we wouldn't need much more than just a video recording, which is that's kind of the nice thing about the video measures is you can get a lot with very like easy access to instrumentation, you know, a webcam. But yeah, we have done like on-premises eye tracking and stuff like that.
You can imagine a focus group setting where it would be interesting to have different camera angles
Yeah,
to look for various dynamics, like you were talking about contagion or, yeah, how they react to
that's
different.
probably how we
signals.
tried to design those rooms that we have in our lab. You know, I know they wouldn't fit more than say 4 or 6 comfortably, but we only have the 3 cameras installed there, but we can add cameras to that system in a room. We have more interfaces to plug into that network, add cameras on tripods or something.
Yeah.
Or it's on Zoom.
We're just on Zoom, yeah, and we have experience using Zoom for all this. That's what we looked at.
And we just kind of had to tell participants in advance always, like what to pay attention to, right? With the light on and.
Yes. Yeah, to be a direct. Well, I'll power this up if anybody wants to look at the computer. Questions?
This is great. Yeah, I mean, I really appreciate it.
Follow up with me, email us if you want to pursue this further, or if you have a research idea or you just have questions.
Now, what's the best contact email? Is it the one that,
The WBL contact, you know, wherever you got this from, or me, I'm bought at BOTT. I should put that on a slide. That one.
Yeah.
You should just check with them.
It was just like quick introductions.
Oh, yeah, please.
Yeah, I'm Rich Schweitzer. I'm the one in academic director. I've been super interested in analyzing video, but I haven't done it yet. But I've been tempted, and actually seeing you present it, it gave me some ideas.
Excellent, yeah.
But it seems, I mean, it's sort of, you know, costly. Like it's just a flood of data.
Oh, yeah, I
I'm
mean,
be careful about.
this is only the very beginning, then we dump a huge CSV file on you and you figure out what to do with it.
Yeah.
Then the fun really begins.
Yeah.
Hey.
Hey.
We're sort of,
Mary told us to come over. Yeah, Mary told us to come over.
come over and eat, like grab food.
Okay.
This is
Okay.
sort of our lab staff.
Yeah.
Hi, everyone.
Thank you for coming in. You were in some of the videos.
Oh, nice. I know.
Yeah.
That sounds fun.
I think it was just that photo of you and Sue in the.
I love that. That was a whole photo
Back
shoot.
in the day,
I love that.
We did have quite a photo shoot.
Yeah. Posing, giving the patients. Cool.
Okay. I'm a postdoc. I'm Max Garrett. I'm a postdoc in marketing department. I recently joined from Germany, but I'll be here for 2 years working with Kate Lambert.
Yeah, but we've been talking about touch.
Yeah, exactly. Touch beds as well. And I'm really interested in using this technology for tracking boredom in
Yes.
digital interfaces. And as to whether boredom is usually the status symbol, that's basically.
You can try it on my class.
Yeah, I know. So I think students are a very good sample for it.
I'm Vera Ludwig, and I'm a postdoc working with Michael Platt and also with the Public Psychology Center sometimes. And I'm interested in how people connect and
Psychology?
connection and well-being.
In psychology.
I like neuroscience.
Yep.
Thank you.
Me? Okay, well, I'm Beth Simmons and I'm a professor in political science, law, and I have a secondary appointment in Wharton as well. And Biz will introduce herself. We're working together on a project that is trying to understand what kind of traumas people experience when they cross an international border. So, you know, then we probably will plan some manipulations around how you encounter border patrol, how you encounter the architecture at a border crossing, trying to sort of ferret out some of the emotional response there may be to that kind of a visual stimulus. And the reason I was asking all about, can this be done like with focus groups, and do you take it out of the lab setting, is we can imagine maybe designing a project that has more to do with thinking about immigrant communities and refugee communities and comparing them to a university population, for example. So that's what we do.
I'm Biz Herman. I'm a postdoc with Beth. I'm in political science, but I do a lot of interdisciplinary work and focus a lot on trauma. And yeah, so Beth explained what we're hoping to do very well.
Thanks for coming over.
Yeah.
Great for outreach. And
Al Clement, I run the research and analytics group within Wharton Computing. Robert and Bob are part of that, and research programming team, high performance computing. So we've done a lot of work that ends up in the lab, or we help analyze work that comes out of the lab. One thing, we are working with a researcher to build a pipeline to do these types of videos at scale. So it does transcription. It uses OpenFace, which is it's an open.
so there's OpenFace, which is facial expression analysis in open source. Hasn't been updated in a while, and I don't know how its model, like machine learning model, compares to
that.
I would imagine
It's in the same space. But one thing that this researcher's using is it's called Open Smile, which sounds like it's about faces, but it's actually about paraverbal. So it's not the transcription of the words, it's how you say the words, which could be a way of balancing out the difference between the actual language and what the face is doing. There's also the tone.
And
in there
inflection.
too, which is inflections and everything else. So that could be of use.
exactly. No, I think that's
I don't know how accurate that library is, but
Right.
it's big.
that is like a missing piece I've been wanting to bring into cities analysis. We do most of the audio analysis we do ends up going into the text domain, and I think you just
You lose a whole layer of data for sure.
I'm Sue McCafferty. I run all of the online studies, so MTurk, Prolific, Qualtrics specialized panels. If you have questions about that, that's my domain.
Bob Stewart.
Bob Stewart, I'm an IT specialist in the Wharton Behavioral Lab, and so I help support all the hardware and software involved.
The camera system had a lot more problems. They did have a lot of problems. Oh, I'm sorry, yeah.
Semi affiliations here from psychology and marketing. By the way, my name is Hugo So, and I'm doing mainly the work in behavior change. I'm also interested in this methodology. That's why I come here.
One question, do you know if it's common to smooth the data from Architiva? I thought like maybe each frame could be meaningful, right? Like the tiny little micro expression, maybe it's meaningful.
Right, microexpression is actually the core of a lot of this research, that there is a kind of a hard line just physiologically that your face isn't going to move faster than 50 milliseconds between, I think it's around, usually as a rule of thumb, 100 to 200 should capture most. 100 to 200 milliseconds really is probably like a 5 to 10 hertz that sample is probably for capturing all those micro expressions. But yeah, so in terms of smoothing, I believe there's some internal smoothing already occurring. So one of the documentation of that from the software itself. And then, but yeah, we usually do a fair amount of like either upsampling or downsampling by either downsampling the video itself or by doing some kind of window aggregation on them.
So when you, do you also provide, or is available, like, is there any different, is there available any markers for demographic differences between people? So for example, when you deliver data, if it's done in a lab, okay, they're all going to be between 18 and 22, probably.
Well, kind of, we do have a pretty, so I should mention, we have a staff population from Penn that's pretty active in our lab. So the age ranges might be bigger than yours.
Yeah. I mean, would we get gender? Would we get race? Would we get?
From the Wharton Behavioral Lab? Absolutely.
Yeah, okay.
among the individual differences, though, you'll get from facial expression analysis, like a lot of machine learning, there's a history of using primarily white populations, so you just have to be aware of that.
Yep.
Great, thanks so much. Robert, thank you for sharing this.
Sure.
This is the kickoff. Welcome suggestions for future.
I mean, yeah, I would almost like, do you think we should include maybe one, for things like this in the future, like would this have been better? If maybe also something like Vera presented a little bit of research that using this.
Yeah.
I mean, it would have been helpful.
Or maybe even as a separate thing, but I would really like to.
Yeah, yeah, I was eager to just sort of. kick
No,
off-
I want to do like a nuts and bolts and here's everything we have.
Here's what we have. Yeah, my goal is for what we have left to be a resource, not just to run studies, but also to build some community that we can learn from each other about how we actually can use our methods to answer questions.
Yeah.
So this is it's sort of in that vein. We're kicking off and it's a slow.
Something like workshops in progress kind of thing, papers, projects in progress, and in development and at various points actually of their beginning design phase to some kind of finished product and what we got out, stages in between. Be interesting to see.
Yeah, so that's the idea.
Yeah.
And video is like, one cool frontier that we're lessening.
We are just acquiring some new eye trackers. Hopefully soon they're in the mail. So we'll definitely do one of these with eye tracking soon once we get a handle on it.
Could provide some slides once we get that analyzed or.
Oh, yeah.
You could talk about.
Yeah, and that would be good, like, it doesn't have you, if people like doing eye tracking.
Just the facial recognition.
The facial expression stuff,
Yeah,
yes.
eye tracking.
I guess that's all I covered.
How much is your neural net?
Oh, you mean the EEG caps?
Yeah.
That is someone.
That's for the
Forget what's like. I don't think they're from there. It's do you remember their names? I actually have not worked with them very closely.
You mean Jenna and Brian?
Jenna. So they're from Europe, they're from my class lab.
Yeah.
Or from
Associated.
associated with neuroscience initiative or just lab
Right.
lab. Are they associated with the neuroscience initiative or just lab lab?
And they're actually, I don't know. I don't know, just, but they got Michael.
Yeah. They're very self-sufficient if that's not. They've written a lot of their software and they're just using our space.
You don't have any EEGs there, right?
No, we don't.
Bring their own.
Yeah. And in fact, we discontinued the EEG support within iMotions for a number of reasons. I thought it was really poor to begin with. And I believe they dropped support for OpenBCI, which was just the end of it. So, yeah, doesn't make any sense. But anyway, we have trained our staff occasionally on fit of a cat, for example, and testing and doing the reporting. Often help. But we have, and if there is consensus on a cap and a piece of software that everyone wants to use, there's enough demand, then we'll evaluate whether we want to make an acquisition and get each. It's just been so varied over the years. It's every time we do an EEG study, it's different technology.
And we're still struggling also to find the best one for the
Exactly.
easy mobile ones. I think the corporate one will be
Good.
developed.
Yes.
If I wanted to develop a capacity for my team to interface with your team, because my body of knowledge is so different from your body of knowledge, what kinds of, would I want to be recruiting computer science majors to my team to help with that? Or is this at a general level that anybody could kind of get technically trained on how to work with your lab, and then they could sort of relay that to us and kind of keep us apprised and informed and sort of help with that a little bit with that interface? What kind of students would I want to recruit? What kind of skills would they need?
I think general skills is fine. I think on the computer science,
Yeah.
software engineering side, Alex's team helps for Wharton projects.
Okay.
We can help a little bit too.
So I'll be looking
There's
at a
not
bunch of, I'll
always-
be looking at a bunch of CVs and I just need to know what do I need to look
Yeah,
for?
there isn't always, say, programming experience required.
Okay.
It really depends.
Good to know.
Great. All right, thank you.
Thank you.